Hi all. A few of my friends wanted me to discuss about our neighboring planets. So I chose Mercury. My first video was on planet Neptune, which is the farthest from our sun. Mercury is the closest to our sun. Let's talk about it. Mercury's orbital path is very close to the sun. Therefore, early civilization believed it was two different stars, one which appeared in the morning and another which appeared in the evening. Because of the planet's proximity to the sun, it travels at a tremendous speed. The Romans, who were observing the planet at the time, named it Mercury, after their deity who was known for delivering messages very fast. As a fun fact, the Greek version of this deity was called Hermes. No one really knows the exact date of Mercury's discovery. It was historically mentioned about 3000 BC by the Sumerians. Astronomers did not realize that Mercury was a planet until 1543, when Copernicus published his sun-centered model of the solar system, putting the sun as a center of the solar system rather than previously believed the Earth as a center. So far, only two spacecrafts have visited Mercury. One is known as Mariner, which was launched in 1974. It flew by Mercury 3 times. During this time, they were able to map just half of the planet's surface. On March 24, 1975, scientists believe it ran out of fuel and still believed to be orbiting the sun. On August 3, 2004, the Messenger probe was launched to explore high density, geological history, and the nature of its magnetic fields. Being close to the sun, the planet is not easily seen except during twilight. It is gravitationally locked, and this makes the rotation is unique within our solar system. Every 7 years or so, Mercury can be seen from Earth passing across the face of the sun. This happens because Mercury's orbit is inclined by 7 degrees to the planet's Earth's orbit, and it is also known as transit. Only 5 planets, including Earth, are visible with naked eye. Mercury is just 4,880 kilometers across its equator, compared to planet Earth 12,742 kilometers. Mercury also has the highest orbital eccentricity of all the planets, with its distance from the Sun ranging from 46 to 70 million kilometers. A year on Mercury is just 88 days long, yet a Mercury day is 176 Earth days. Mercury is nearly tidally locked to the Sun, also known as gravitational lock, and over time this has slowed the rotation of the planet to almost to match its orbit around the Sun. Because of low gravity and lack of atmosphere, Mercury has no moons or rings. Scientists have found that planet has wrinkles. As the iron core of the planet cooled and contracted, the surface of the planet became wrinkled. Scientists have a name for this: lobate scarps. These scarps can be up to a mile high and hundreds of miles long. Studies of Mercury show that the planet has shrunk by about 11 kilometers since the birth of our solar system, which is about 4.5 billion years ago. Mercury is the most cratered planet in our solar system. Unlike Earth, which is self-healed through natural geological processes, Mercury's craters are named after famous writers, artists, and composers. The largest crater is called Caloris Basin, which is about 1,550 kilometers in diameter. This crater was formed by the impact of a large meteorite in the early formation of the planet. It was discovered by 1974 Mariner 10 probe. Mercury is the only second hottest planet. This is because there is no atmosphere to regulate the temperature. This results in most extreme temperatures changes, ranging from negative 170 Celsius to positive 430 Celsius during the day. Mercury is the second densest planet. Even though the planet is small, Mercury is very dense. For example, each cubic centimeter has a density of 5.4 grams, with only Earth is having higher density. This is largely due to Mercury being composed mainly of heavy metals and rocks. Studies reveal that Mercury and the other unusually metal-rich objects in our solar system may be relics left behind by hit-and-run collisions in the early formation of our planets. Furthermore, the studies reveal scientists have come to believe that a solid iron core of Mercury could in fact be molten. Normally, the core of small planets cools rapidly. After the extensive research, the scientists were not in line with those expectations. The orbit of Mercury is an ellipse rather than circular. It is most eccentric among 8 planets. German astronomer Johannes Kepler models predicted accurately the orbital motion of most planets to a high degree of accuracy, except for planet Mercury. Early astronomers, also been observing for 2 centuries, had been aware there's a small flaw in Mercury's orbit around the Sun, as predicted by Newton's law. Due to its proximity to the Sun, Mercury orbits a region in the solar system where space-time is disturbed by the Sun's mass. Mercury's elliptical path around Sun shifts slightly with each orbit, such that its closest point to the Sun, also known as perihelion, shifts forward with each pass. Newton's theory had predicted an advance only half as large as one observed. However, Einstein's prediction exactly matched the observation. This is where Einstein's genius comes into play. In 1915, he published General Relativity theory. Basically, it's a geometric theory of gravitation. He basically refined the Newton's laws of universal gravitation, but providing a unified description of gravity as a geometric property of space and time, or also known as 4-dimensional space-time. In particular, the curvature of space-time is directly related to the energy and momentum whatever matter and radiations are present. Mercury has a very thin atmosphere, which made up of atoms from the surface of the planet that have been blown away by solar winds. As Mercury is so hot, these atoms quickly escape into space, and so its atmosphere is constantly being replenished. Another fun fact here, Mercury has a very weak magnetic field whose strength is about 1% of magnetic field on Earth. The last slide talks about the latest mission to planet Mercury. The mission's name is Bepi-Colombo. It is named after an Italian scientist, mathematician, and an engineer who lived during 1920 and 1984. He first proposed the interplanetary gravity assist maneuver. This concept was first used by the 1974 Mariner 10 mission, a technique now used frequently by planetary probes. The mission comprises of 2 satellites launched together, the Mercury Planetary Orbiter and Mercury Magnetospheric Orbiter. This was already launched on October 20th, 2018. However, we will have to endure a 7-year wait before the project's science begins. On April 13th, 2020, Bepi-Colombo flew by Earth. 2 flybys of Venus in 16th of October 2020 already gone, and one is expected to go around August 2021. The 6 flybys of Mercury and 15 flybys of Sun, all between year 2021 and 2025, will happen. Each flyby will tweak the spacecraft orbit just a little, nudging it closer and closer to the mission's target, December 5th, 2025. These flybys also helps the engineers to make sure many of the instruments on board are working. Why so many flybys? Mercury is so small and so close to the Sun. That means planet orbits the Sun at an incredible speed. We already discussed about it. and a spacecraft hoping to visit the innermost planet must travel pedal to the metal in order to catch up to the swift world. But there is a big catch here. The sun's gravity will pull the spacecraft so strongly towards the sun that craft actually needs to brake throughout its cruise to avoid getting tugged off course. In order to tackle this dual challenge, Baby Colombo drivers have carefully devised a combination of solar power, chemical fuel, and planetary flybys, which will work together to steer the spacecraft through the celestial obstacle course. Thank you for watching. I hope you enjoyed this video. If you haven't subscribed to my channel, please do so and click the bell icon. Also share it among friends and families. I will see you in my next video. Cheers.